Hello, we're contestant number 15057. This is our project for additive manufacturing.
Our problem was to help people who are shorter or have disabilities reach higher places, or just give them a helping hand.
So the products we saw out there that decide that we're going to help people who are shorter and need a helping hand were products like stools and products like grabbers. Products like those are really out there. They're very elaborate and they're not very low key. And they're pretty big, bulky, and non-versatile. Like imagine going to a grocery store and pulling out a stool. Like who would do that? So that's why we decided to change that.
Therefore, our design came compact and expandable. It could start from 8.5 inches and expand all the way up to 21. We did this by making it tapered at about 0.22 degrees and is consistent of 4 stages, which expands, making it a telescopic design. We modeled this on Autodesk Inventor, and we incorporated universal design by adding those armbands on one end of that to help people grasp onto it better. On the other end, we also include pegs, which would be on the print, but due to some issues that arose, it can't fit in properly due to an issue that we'll cover later. But as you can see on the model, it fits here correctly. It's just minor issues that came along during the print. Another thing that makes our design special is that we decided to focus on the shape of it, and we, instead of making it circular like other telescopic things you may have seen in the past, we made it polygonal so that way you won't have to worry about twists and turns. And finally, it took us about 2 days between the two of us to design and to model the entire thing. And that's it.
Right. So the first thing we thought of was material. What kind of material should we use? So for a print like this, we decided that we wanted it to be print in place. And print in place meaning that we print all of these together all at once. So that way we can speed up the manufacturing process, meaning that you have no real assembly after the print is done. And the only real way, the main reason we chose that is because this bend over here, this bend means that we can't place these on top of each other. They have to be printed in place. So we decided to use PLA to fix that problem. PLA doesn't expand much and it's generally a pretty durable and sometimes you can bend it pretty easily, meaning that it won't generally snap much. And this is a problem we actually had was that we tried using PETG for our pegs. PETG tends to expand a little bit and we didn't account for that when trying to use PETG and PLA together. So that's something we need to improve on. But we also decided that, but through this process, we use the model from the STL. We transfer that into Ultimaker Cura. And from Ultimaker Cura, we can put that to be its print in place. So from there, we have our settings that we set to use. PLA generally runs off of a 200 Celsius. Well, it generally runs best off of a 200 Celsius nozzle temperature. And then the temperature for the bed, we use a 65 Celsius. And for adhesion, we use a glue stick and wraps. That allows it, you rather have your print have a little extra filament and take a little extra time rather than losing all a bunch of extra filament on a failed print. So how long this took to actually make was around about a day and 7 hours, and maybe 30 minutes or so. Generally, print depends on the printer. Sometimes it goes a little faster, a little slower, give or take. But for a print that's this big, actually that was pretty fast. That's around 200 grams of filament, taking about a day and a quarter or so. And that's not too bad actually. But some places of improvement or these armbands did need supports, and these did cost us quite a bit of time. So if we were going to change the design a little bit, we'd probably take away these supports. We'd probably take away these armbands and use Velcro straps, so that we incorporate universal design even more for all demographics. We're having bigger, smaller arms, and give or take even more processes. So For our cooling, because PLA does require cooling, it needs 100% cooling, and then it also needs this print in particular needed about a 0.2 millimeter layer height. We also used an octet pattern, and then we also decided to use a Prusa and Ender 3. I'm going to show the Ender 3 real quick through this camera. Ender 3, filament, Ender 3, and then the bed you see has some glue resin. So that's what we had for our project.
Overall, I feel as though we did accomplish the goal of what our problem was, to help people who are shorter or have disabilities reach higher places and be able to truly be able to grasp things in a more convenient way than what was available prior. And thank you for your time.
You